Let's talk about the formation of mountains. What is a mountain? Well, that's easy. A mountain is just a large mass of rock that rises a great distance above its base. Mountains tend to form in mountain belts, and the mountain belts tend to form on the edges of the continents. Here in the darker color, these are all mountain belts. And if you think about plate tectonics, these are also areas on the edges of tectonic plates. So mountains usually form where there are convergent continental margins. So when we have continental plates collide, the continental plates crumple up and form mountains. Let's watch an animation. Here's India crashing into Asia. You'll notice that there was an ocean between them, and as that ocean got smaller and began to close, we had subduction going on as an oceanic plate dove underneath Asia. But watch what happens when India finally does collide with Asia. That oceanic plate breaks off and sinks deep into the earth. This continental plate does not sink below this continental plate, but they collide and they cause mountains to form. We also get volcanic mountains whenever we have subduction of an oceanic plate below a continental plate. We don't get mountains form at passive continental margins, just at active continental margins. Whenever we have convergent plate boundaries, we have stress that begins to build up. The rocks near the surface will break when they're subjected to stress, but rocks that are buried deep in the earth, that are under great pressure and heat, will fold and bend and stretch. They don't just break, but rocks near the surface will break. Rocks that are deep in the earth under heat and pressure will fold and stretch. Now there's three types of stress that build up. One is compression. Compression is just side to side force. This force moving this way, this force moving that way. They're balanced, and so they cause the deeper rocks to fold and to bend. We can also have tension. Tension is when you basically are trying to pull these rocks apart. You got force in opposite directions on either side of these rocks will cause them to stretch. Shear is a type of stress where you have force moving in this direction and force moving in this direction, but they're not balanced against each other, so it distorts the rocks. Compression, tension, and shear cause rocks to fold when they're buried deep beneath the earth at convergent plate boundaries. And they cause two types of folds. One's called a syncline. This is an example of a syncline, so the rocks are going to fold downward, make a downward fold. And the other type is called an anticline. An anticline is just the opposite. The rocks fold upwards. They make an upward bend, like a dome. So at convergent plate boundaries, compression usually causes the rocks to fold and create folded mountains. So what you end up with are a series of synclines and anticlines. Think of it as kind of like an S-shaped curve. And that's because we're pushing inward from this side and inward from that side, causing compression. Here's an example of some folded mountains in the Canadian Rockies. Here's another example of the Rocky Mountains in Canada. Look how folded these rocks are. Just think of the enormous pressure and compression that it would have taken to fold these rocks. Now, compression, tension, and shear cause rocks at the surface of the earth to break. They don't fold, they don't bend, they break. And these breaks are called faults. So a fault is a break in the rocks, break in the lithosphere, where there's movement. And different types of stress cause different types of faults. We need to learn some terms, and these terms came from miners. It turns out that faults or cracks in the Earth's surface tend to create conditions where ores will accumulate. So when miners were mining ores, say for gold or silver, other metals, they were tunneling along these faults. And they developed some terms: hanging wall and footwall. The footwall was the part of the fault that they walked on, and the hanging wall was the part of the fault where they hung their lantern. All right, here's a close-up of it. So as they're tunneling along this way, along the fault, removing the ore, this part of the fault would be called the hanging wall, and this part would be called the footwall. Tension causes what we call a normal fault. So if we stretch the rock, then we get what's called a normal fault. And what happens is the footwall moves up and the hanging wall moves down. As you can see in this animation, we're stretching the rock, and the footwall moves up and the hanging wall moves down. So in this diagram you can see here's our fault. We have tension that's pulling this rock this way and this rock this way. The footwall is going to move up and the hanging wall is going to move down. Compression causes what we call a reverse fault. So if we push in this way and in this way on the rock near the surface, it's not going to fold like in this diagram. It's going to break, and it's going to create a reverse fault. In a reverse fault, the hanging wall moves up and the footwall moves down. So we'll watch this again. The hanging wall is moving up, the footwall is moving down. And here's a diagram that shows it. So the hanging wall is going to move upward and the footwall is going to move down. That's called a reverse fault. Shear causes what's called a strike-slip fault. It's kind of like compression, only these forces aren't balanced against each other, so the rock tends to get what we call sheared. And it causes this type of a fault, where the rock moves sideways. The classic example of this is the San Andreas Fault in California. So shear causes a strike-slip fault. Now faulting can cause a type of mountain called fault block mountains. And there's two types of these. Tension will cause a normal fault, right? Well, if we have two normal faults, then this block in the middle will move downward. It'll basically drop. That's called a graben. And it would form two mountains on either side separated by a valley. The opposite of that is called a horst. A horst forms from compression. Think of it as two reverse faults, one here and one here. This block is going to move upward. This is going to create a mountain here. That's called a horst. And there's our horst. So the block that moves upward now is going to form our mountain, and forms from compression. If you go to Nevada, there's an area called the Basin and Range. This was caused by stretching of the Earth's crust, which caused blocks of the Earth's crust to sink down and created these parallel mountains with valleys in between. Another type of mountain is called a dome mountain. Dome mountains form when rock is pushed upward from below, And that can happen from a pluton, a large mass of magma moving upward against the crust, or sometimes tectonic forces can cause a continental plate to warp upwards. And this is the type of force that would cause a dome mountain. Something is pushing up from below, a pluton or tectonic forces. And that's what a dome mountain would look like.